Hello students, welcome to RD Chemistry. Let us see some questions in haloalkanes and haloarene. The first question is the major product in this reaction. Now there is an alkene here and HBr. Alkene and HBr follows Markovnikov's rule, correct? That means the positive part of the reagent gets attached to the double bonded carbon atom containing more number of hydrogen atom, and negative part goes to that carbon containing lesser number of hydrogen. But you see here, the carbon-carbon double bonded carbon atom attached to the same number of hydrogen atom number 1, one hydrogen only. So I can add a hydrogen here. If I do so, then it becomes single bond. Then there is a positive charge here, carbocation. So it is a carbocation mechanism. This carbocation generated is a resonance stabilized, which is more stable when compared to if the carbocation is generated on this carbon atom. So now therefore add the bromine to the more stable carbocation here. That is the benzyl carbocation. So therefore I can expect a benzene ring attached to CH. Since you get a positive charge, so this is a bromine attached, nuclear attacks. Then it is a CH2, then a CH3, right? So this follows Markovnikov's rule to give more stable carbocation. Fine. So what is the answer? Answer is option number 2. Clear? Question number 2. A in the reaction is there is a bromo compound given, there is alkene, there is alcoholic KOH. What is the role of alcoholic KOH? It acts as a dehydrohalogenating agent. Dehydrohalogenating agent. So dehydrohalogenation takes place. So I can write CH3, CH2, then CH, then here CH2, then CH double bond CH2. Correct? I can remove hydrogen from here, right? To give HBr. I can remove hydrogen from here also to give one more HBr. Either double bond is created here or created here. Now, which compound will be more stable? Now, there already an alkene is a carbon-carbon double bond, single bond. If there is a carbon-carbon double bond again, conjugation, then that alkene will be the more stable alkene. So, extended conjugation makes alkene more stable alkene. Okay? Therefore, answer is option number 1. Clear? Question number 3. Alkyl chloride reacts with the AgCN. AgCN is the covalent compound between silver and carbon. There is a covalent bond. Okay. Therefore, here nitrogen acts as a nucleophilic center, attack the carbon atom. Nucleophilic substitution take place to give the compound RNC. 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 Okay. If I write in terms of charges, plus charge and minus charge, or if I write in terms of the covalent bond, it would be like this. Correct? Then reduction. Reduction means generally addition of the hydrogen. Break this nitrogen carbon multiple bond and convert into R, N, H, carbon, and attach hydrogens to the carbon atom. So final should be CH3. So it should give like a secondary amine, RNHCH3. Therefore, the answer is option number 2, RNC and RNHCH3, right? Question number 4. In the following reaction A and B are. Now this is a tertiary butyl bromide. So tertiary alkyl halide. Now there is a ethyl alcohol given. Ethyl alcohol. Ethyl alcohol is a polar solvent. Polar solvent. and ethyl alcohol act as a neutral nucleophile. Okay. So it favors SN1 mechanism where the bromine atom ionizes to give tertiary carbocation. Then the nucleophilic OH of ethyl alcohol attack the carbocation to give the ether compound. That is there in option number A1 and option number 3. Okay. Now see the B reaction where ethyl alcohol is a solvent here and its salt act as a stronger nucleophile because a negatively charged, okay, negative charge nucleophile. So stronger nucleophile, remember stronger nucleophile. Stronger nucleophile always, okay. Now in this case should give SN2 reaction, but it does not give SN2 reaction because the alkyl halide is tertiary. So in this case strong nucleophile will act as a base. So it can bring about dehydrohalogenation. So tertiary butyl bromide undergoes the dehydrohalogenation, removal of hydrogen and halogen from the neighboring carbon atom to produce an alkene. Okay. Therefore, answer is option number 3. Hope this is clear to you. Right? Bottles containing the iodobenzene and benzyl iodide were lost their labels and they are labeled as NB for testing. Okay. And separately taken a test tube boiled with the sodium hydroxide and the reaction made acidic and with the dilute nitric acid made acidic and some silver nitrate is added. Substance B gave yellow precipitate. Which of the following is a true statement? Okay. The yellow precipitate definitely because of the silver iodide that is formed, which means iodine should break from the benzene or iodine should break from the side chain here. Okay, this one. Okay, but you should remember that aryl iodides or aryl halides does not easily undergo cleavage because they are involved in the resonance. Therefore, compound B should give the yellow precipitate means we treat with the sodium hydroxide solution, right? You should give the benzyl alcohol because of the nucleophilic substitution reaction, okay? And you should give the sodium iodide. The sodium iodide is then treated with the silver nitrate to give silver iodide, which is a yellow precipitate, okay? So B gave the yellow precipitate. That means benzyl iodide should be in test tube B and iodobenzene should be in test tube A. Therefore, answer should be which one? So we can go for option number 1. A was the iodobenzene and B was benzyl iodide. Clear? Question number 6. On mixing certain alkane with the chlorine and irradiating with the ultraviolet light forms only one monochloroethane. The alkane should be. If it gives only one monochloroalkane, all the hydrogen present should be of same type. Okay. So if I go for neopentane, one carbon is attached to four more carbon atom, and to satisfy the valencies, hydrogen are there. Okay. Now we see carefully all the hydrogens and all the types of carbon atom are same. Correct? Whether replace this hydrogen or this hydrogen or this hydrogen, it can form only one type of monochloro compound. In other cases, there are more than one type of hydrogen is present. Okay. So in these cases, if you see carefully, all are primary hydrogen atoms. Clear? Therefore, answer should be option number 4, neopentane. Question number 7. The compound 3 times CH3 like tertiary butyl type, and the carbon attached to Mg and Cl. You know, this is Grignard reagent. This is a Grignard reagent. So we have got, this is the positively charged and this is the negative charge. Okay, RMGX, RMGX, R is delta minus and MGX delta plus. D2O. D2O is acidic. Okay, just like water molecule. D plus OD minus, like we write H plus and OH minus. So acidic hydrogen is there. So acidic hydrogen is taken by the negative part. So deuterium it takes. Therefore, compound should be finally CH3, then CH3, then CH3. This negative charge should take up the acidic deuterium. Okay. So the answer is option number 1. Clear? Question number 8. The order of reactivity of following alkyl halide for SN2 reaction. Generally for SN2 reaction, primary alkyl halide react faster compared to secondary compared to tertiary. If you bring methyl halide, then methyl halide comes in the beginning. Methyl halide. Now here, all alkyl groups are same, correct? So they are given propyl, propyl, propyl everywhere. So among halogen, which one is a better leaving group, which can be easily displaced? That is the iodine. Then comes the bromine, then comes the chlorine, then comes the fluorine. In this order it goes. Okay. So what is the answer? Answer is option number 4. Option number 4. Clear? Question number 9. Which of the following arrange in the decreasing order of the dipole moment? Generally, we say as the electronegativity increases, which is attached to the carbon atom, its dipole moment also increases because dipole mu is equal to the distance between the two charges into electronic charge. As the electronegativity increases, charge also increases. Okay. So accordingly answer should be fluoro compound should have the more, like methyl fluoride should be more, then methyl chloride, then methyl bromide, goes on like this, correct? But okay, we also take care of the distance between the two centers, like carbon fluorine, carbon chlorine, carbon bromine. Okay, when you put all together, actually not the fluoro compound comes first, actually the chloro compound first. That is option 3 is the actual answer. So mu value not only depends on the E electronic charge, it also depends on the D. Therefore, it is a product of two, E and D. So therefore, methyl chloride is more, has more dipole moment compared to fluoro compared to bromo compound. Okay, so the answer is option number 3, right? Question number 10. In the reaction, alcohol reacts with the HX to give alkyl halide, the order of reactivity of different alcohol. So alcohol reacts with the HX, H plus and X minus. Actually, the protonation occurs and get carbocation, then X minus should attack here. So it is a carbocation mechanism here. So tertiary carbocation more stable compared to secondary compared to primary. Therefore, halide easily attacks later tertiary to give the more stable compound. Okay. So therefore, tertiary carbocation easily forms. So tertiary alcohol easily reacts. Therefore, answer is option number 1. Tertiary greater than, secondary greater than primary. That's all for today. Thank you for watching. Have a nice day.